Hello and warm greetings to everyone. I welcome you all to my YouTube channel, Fly Stellar Aeronautics. My name is Priyanka and I'm starting a series on aviation topics. So today we will be discussing about atmosphere. Before we take a look at what is atmosphere, let's understand the basic difference between weather and climate. Weather is what you get, whereas climate is what you expect. Weather is the conditions of the atmosphere over a short period of time, whereas climate is how the atmosphere behaves over a long period of time and space. Weather can change within minutes or hours, whereas climate is an average regional weather pattern over decades. Study of weather is called meteorology, whereas study of climate is called climatology. Weather is affected by temperature, air pressure, and moisture, etc., whereas climate is affected by the climate system as well as altitude and latitude. What is the atmosphere? It is an envelope of homogeneous mixture of gases called air. It surrounds the Earth and is attached to it due to Earth's gravitation. Composition is as follows: 78% is nitrogen, 21% oxygen, 0.03% carbon dioxide, and other gases. Maximum concentration of ozone is between 20 to 25 kilometers. Layers of atmosphere. Atmosphere is divided into different layers based on temperature. Each layer has its own peculiar characteristic, namely troposphere, stratosphere, mesosphere, thermosphere, which has ionosphere, and exosphere. 99% of total mass of atmosphere is confined to 32 km from Earth's surface. You can remember it as a sigma. First layer of atmosphere is called troposphere. It is the lowest layer of Earth's atmosphere. Tropos means change. Since all weather changes occur in this layer and air never remains static, it is called troposphere. In this layer, temperature falls with height, which is called lapse rate. As you can see here, that the temperature is falling with height, that is at 6.5 degrees Celsius per kilometer. But why does the temperature fall with height? The reason is that troposphere's gases absorb very little of incoming solar radiation. Instead, the ground absorbs this radiation and heats the tropospheric air by conduction and convection. So the air near the ground is heated, and as the air rises, it cools down. Thus, the temperature falls with height. Troposphere extends to 16 to 18 km over equator and 8 to 10 km over poles. But why does the thickness of troposphere vary? It varies because of high insolation near the equator, air is less dense at equator, centrifugal force is maximum at equator, and gravitational pull on atmosphere is more at poles than equator. All weather phenomena like rainfall, fog, hailstorm occur in this layer, as all water vapor and solid particles lie within this layer. Next is the tropopause, which is between troposphere and stratosphere. It acts as a boundary between them. In this, the temperature ceases to fall with height. This layer has a constant temperature, as you can see here. Above tropopause, temperatures are higher over poles than equator. Thus, there is a reversal of temperature and density above 8 km. There are breaks in tropopause at 40-degree latitude and 60-degree latitude where jet streams occur. And in India, it is found at 16 to 16.5 km. Second is the stratosphere. It is the second layer of atmosphere above troposphere. It extends above troposphere up to 50 kilometers. Initially for 8 to 10 kilometer, the layer is isothermal, that is no change in temperature. Then the temperature increases with height. But why does the temperature increase with height in stratosphere? It is because of absorption of UV rays of the sun by ozone present in this layer. So yes, ozone is present in stratosphere. It is a stable region with no weather and low humidity. This layer is very dry as it contains little water vapor. This layer provides some advantages for flight because it is above stormy weather and has steady, strong horizontal winds. Nacreous clouds or mother of pearl clouds are seen here. Stratopause separates stratosphere and mesosphere. The third layer of atmosphere is called mesosphere. It is found above stratosphere. It starts at 50 kilometers above the surface of Earth and goes up to 80 kilometers. The temperature drops with altitude in this layer. But why does the temperature drop with altitude? It drops due to lack of absorption of UV rays. By 80 kilometer, it reaches minus 100 degrees Celsius. It is the coldest layer of atmospheric layers. Noctilucent clouds are seen here. Meteors burn up in this layer of dense air due to creation of friction and a lot of heat. The upper limit is called mesopause, which separates the mesosphere from thermosphere. The fourth layer is thermosphere. This layer is found above mesopause. Temperature increases with height due to absorption of high energy X-rays and UV radiation of the sun, which causes few particles present to heat up considerably. This layer is cloudless and free of water vapor. Thermo means heat and can reach up to 2000 degrees Celsius. It also results in photoionization and thus contains ionosphere. Photoionization is breakup of gas molecules into ions. Ionosphere is important because it reflects and modifies radio waves used for communication and navigation. Most auroras happen in thermosphere. The fifth layer is called exosphere. It is the outermost layer of atmosphere. It extends from top of thermosphere up to 10,000 kilometers. Exosphere contains many of the satellites orbiting Earth. Earth's gravity is extremely weak in exosphere. The outer part of it is called magnetosphere, and the final boundary between Earth and outer space is called magnetopause. Next, which is extremely important, is International Standard Atmosphere, in short ISA. It is the most widely used atmosphere defined by ICAO. Its specifications are: air is dry, temperature at mean sea level is 15 degrees Celsius, pressure at mean sea level is 1013.25 hectopascal, density at mean sea level is 1225 grams per cubic meter, acceleration due to gravity is 980.665 centimeter per second square, lapse rate up to 11 kilometers is 6.5 degrees Celsius per kilometer. Temperature is assumed constant at minus 56.5 degrees Celsius from 11 kilometer to 20 kilometers, and from 20 kilometer to 30 kilometer there is a rise of temperature at the rate of 1 degree Celsius per kilometer with a temperature of minus 44.5 degrees Celsius at 32 kilometers. Lastly, Jet Standard Atmosphere, that is JSA. ISA values are satisfactory below 30,000 feet but not above this level. For space flights and very high altitude flying and engine manufacturing, additional specific values are required to meet them. Thus, JSA was introduced as follows: mean sea level temperature 15 degrees Celsius, lapse rate 2 degrees Celsius per 1000 feet, and there is no tropopause. With this, we come to the end of atmosphere topic. I hope you found the video helpful and insightful. If you did, then please do like and subscribe to my channel, Fly Stellar Aeronautics. You can also share the video with your friends and colleagues. And don't forget to click on the bell icon to get new video updates on other aviation topics. For any doubts, you can write in the comment section or reach out to me on the following email ID, or you can DM to me on my Insta or Facebook page. I will surely revert to the same as soon as possible. Thank you for watching. I will be back with another video soon. Till then, take care. Happy and safe landings to all. Jai Hind.